Hey everyone, welcome back to another video. So today we'll solve equations using Laplace transform by the table. Hey everyone, so this is our first example of solving equations using the table of Laplace transform. And so we have here f of t is equals to t squared plus 3t minus 4. And so let's solve this by the table using Laplace transform. We write this as Laplace t squared plus 3 times Laplace of t minus 4 times Laplace of 1. You can just leave the 4 inside of the Laplace or the 3 inside of it, but I just like to pull it out to demonstrate using the table so it's clear. And so let's start by solving Laplace t squared here. We can see from the table right here that to solve t to the n when n is greater or equal to 0, it will just be n factorial over s to the n plus 1. And so we know now how to solve for t squared and also for t, which we will have here 2 factorial over s to the 2 plus 1, which is just 3. And so we don't need to write that out. And 2 factorial is just 2 plus 3 times Laplace of t. T to the 1 is just 1 factorial. And that's just 1. So 3 multiplied by 1 factorial is 3 over s to the 1 plus 1, which is 2, plus, or rather, minus 4 times Laplace of 1, and whenever we see 1 here or a coefficient like 4 times 1 or any real numbers times 1, it's just 1 over s. So we have here negative minus 4 over s. And so this is our final solution of solving this equation using Laplace transform by the table. Hey everyone, so this is our second example of today's solving equations using the table of Laplace transform. We have here f of t is equals sine of 4t equals cosine of 4t, and usually people will start off by directly applying sine of a of t here and using the cosine of a of t here to solve this. But remember, if you see this closely enough, we can simplify this equation further using the trigonometric expression, which is 2 sine A times cosine of A. And so, by using this trigonometric expression or relation, we can apply it here, which is 1 over 2 times 2 sine of 4t times cosine of 4t. And so this simplifies to 1 over 2 times sine of 8t. And from here on, we can just rewrite down our 1 over 2. And for sine of 8t, we need to take the Laplace of it. So Laplace of sine of 8t. And by the table, we can see sine of 8t here is just equals to a. Let's write down here. So sine of 8t is just a over s squared plus a squared. And so we have our final answer to this example, 1 over 2 times sine of 80, which is 8 over s squared plus 8 squared, which is 64. We can cross cancel this out, and our final answer will be 4 over s squared plus 8 squared. Let's leave it at that. Hey everyone, so this is our third example for today's solving equations using the table from Laplace transform. And so we have here f of t is equals to e to the t minus e to the negative t, and everything here is squared. And firstly, let's try and solve this equation by expanding this equation out. So we have here e to the 2t minus 2 plus e to the negative 2t. after expanding our equation. And so we can solve this using the Laplace transform by the table. So Laplace e to the 2t minus 2 times Laplace 1 plus Laplace e to the negative 2t. And so by the table, we can see that e to the at here is just 1 minus s, 1 minus 1s minus a. So let's write down here. So before we start solving this, e to the at here is just 1 over s minus a. And so we're ready to solve this equation by the table. So 1 over s minus a, we can see here is 1 over s minus 2 minus 2 times the plus of 1, which is 2 times 1 over s, which is just 2 over s. And then we have here Laplace of e to the negative 2t, which is just 1 over s plus 2. And so this is our final answer of solving this equation by the table of Laplace transform.